This presentation is about the Hughes River watershed. This photograph is of a tributary, not of the Hughes River, but I feel like it represents the watershed pretty well in agriculture and sediment influences. I took it myself while doing TMDL sampling in the watershed. The Hughes River, while having a pretty decently sized watershed, is not very long itself, at only 14 miles long. It's a tributary of the Little Kanawha River, which is in turn a tributary of the Ohio River. Most of the size of the Hughes River watershed comes from the North Fork of the Hughes and the South Fork of the Hughes. The North Fork is 57 miles long, and the South Fork is 54 miles long. Another considerably sized tributary of the Hughes River itself is Goose Creek. Despite the Hughes River's small size, the watershed for the Hughes River stretches 528 square miles. This covers the whole of Ritchie County, West Virginia, as well as parts of Wirt, Doddridge, and Wood counties in West Virginia. Despite this area, the population is only estimated to be about 10,000 people. As the land use statistics later will show you, that's because most of the watershed is forested. And the average watershed elevation is 929 feet. These two pictures, both found from Wikipedia, are essentially the same view of the Hughes North Fork in Caro, West Virginia, and I feel they serve to illustrate the way that weather can completely alter the behavior of the river. This is the South Fork of the Hughes River. This is the Hughes River near Freeport, West Virginia, which is near where the mouth of Goose Creek enters the river. This map shows some main roads and towns of the Hughes River watershed. As you can see, the North Fork and South Fork of the Hughes are considerably longer than the Hughes itself. Several main towns are marked on this map, though I will tell you, from personal experience, they are not very large, hence the 10,000 people population that I mentioned earlier. This land use data comes from the state of West Virginia's TMDL study for the Hughes River. As you can see, the nearly 2% of inhabited land is dwarfed by the amount of forested land in this area. My impressions of the area were distinctly agricultural and oil and gas when I was working there, but even still, that barely even makes up 12% of the land use in the area. It just has a relatively high impact. The designated uses of this watershed include warm water fisheries, water contact recreation, and public water supply. Unfortunately, iron has impaired the capacity of these waters to be used for fisheries, and issues with fecal coliform bacteria have lessened the ability of the watershed to supply water contact recreation and public water. The Hughes River area itself has been divided into 8 smaller watersheds. This includes the Hughes River, Lida Run, Silver Run, Goose Creek, Rock Run, Flint Run, and the North and South Forks of the Hughes. These watersheds themselves were divided into 447 sub-watersheds for the study. This map shows the different watersheds divided up for TMDL in 2014 and 15. As you can see, the North Fork and the South Fork are huge chunks of the watershed. In the 2016 303D list, 100 streams in the Hughes River watershed were listed. They were all listed for fecal, iron, or biological conditions that were not ideal, and many had more than one applied to it. The Hughes River itself was on the 303D list for iron and fecal coliforms. Sampling for the total maximum daily load program for the Hughes River watershed happened from summer 2014 to summer 2015. I worked with the Watershed Assessment Branch of the Department of Environmental Protection during this period of time in both summers, and was able to experience some of the normal water grab sampling, biological sampling, and several fish surveys in the area. TMDL plans were developed for 186 streams, which were determined to be impaired, which is more than the 303D listings from 2016 that I mentioned earlier. 9 of these streams were impaired by only fecal coliforms, 96 streams were impaired by iron, and 81 were impaired by a combination of the two of them. I'd like to take this, another picture I took of the stream from the title slide, as an opportunity to discuss this watershed from my experience doing TMDL sampling. Sedimentation in the watershed was pretty heavy, to the point that if it rained at all, it practically ruled out all biological and fish sampling opportunities immediately. While a lot of the watershed is forested, there's still a great deal of impact on the water from the agriculture and oil and gas itself. Scattered through the countryside were a lot of historic gas and oil wells, and there was larger, more modern oil and gas infrastructure locally as well. Much of the land is rural residential, as in a bunch of skinny, squiggly back roads with very sparse and scattered houses on them. So a lot of the streams you would find were in grassy bottoms and right next to hillsides, next to pastures. I got the bulk of my information from the draft TMDL report for the Hughes River and the draft 303D list for the state of West Virginia from 2016.